In July 2025, astronomers detected something impossible. 3I/ATLAS, an interstellar comet, is glowing toward the sun, defying everything we know about comets. Normal comet tails stream away from solar radiation. This one, a luminous teardrop reaching straight at our star. NASA's data reveals an even stranger truth. The object is accelerating outward with a mysterious force that matches solar gravity's pattern perfectly. The leading theory? A hidden swarm of trillions of sand-sized particles traveling with it, creating 99% of its visible light and generating forces we can't explain. Multiple telescopes across 4 continents confirm it. What's really pulling this alien visitor through our solar system? Let's dive right in. By November 2025, something unprecedented was happening in observatories around the world. From small amateur setups in South America to major research stations across Europe and Asia, astronomers were capturing the same impossible sight night after night. Every clear evening brought another data point, another confirmation of what shouldn't exist. The images flooded in from 4 continents, and every single one showed the same anomaly. A soft, glowing teardrop extending from 3I/ATLAS directly toward the sun. Not away from it, toward it. Researchers checked their equipment. Was this atmospheric interference? A camera artifact? But as independent astronomers verified the observations using specialized filters and different exposure times, the truth became inescapable. The result was always identical. The teardrop feature persisted, always pointing sunward. For anyone who understands comets, this was deeply wrong. Solar radiation doesn't pull material toward the sun. It blasts it outward with tremendous force, sculpting those iconic tails that stream away into space. Yet here was 3I/ATLAS, casually defying centuries of established science with its brightest glow clinging to the sunward side. Online astronomy forums lit up. Professional researchers began sharing findings in real time, their careful language barely concealing the excitement and confusion. The evidence was verified by dozens of independent observers, and it all pointed to the same unsettling conclusion. We were witnessing behavior that our textbooks said couldn't happen. While this visual drama unfolded, NASA's Jet Propulsion Laboratory was uncovering an even stranger piece of the puzzle. JPL's orbital mechanics team doesn't deal in speculation. They work with raw numbers and gravitational calculations that typically predict object positions to within meters over millions of kilometers. But 3I/ATLAS kept breaking their predictions. Every time the team updated their calculations, they had to apply a correction. Small, yes, but persistent. The comet was accelerating outward just slightly faster than gravity alone could explain. Consistently, with every measurement, as if some invisible hand was giving it a gentle but continuous push away from the sun. The team ran diagnostics. They accounted for light pressure, known outgassing effects, even the subtle gravitational tugs from distant planets. The unexplained residuals refused to vanish. The numbers were clear. An outward acceleration measuring approximately 0.00002 times the sun's gravitational pull. Over a single night, that's imperceptible, but across millions of kilometers, that tiny fraction accumulates into something impossible to dismiss. This wasn't noise in the data. This was real, measurable physics acting on an interstellar object, and no one could identify the source. Then JPL's analysts noticed something that transformed confusion into genuine scientific concern. The mysterious acceleration wasn't just pushing the comet, it was doing so with a very specific mathematical signature. Both the sun's gravity and this unknown force weakened with distance in exactly the same way, following an inverse square law. This precision meant the ratio between the mysterious push and solar gravity remained constant at about 0.00002, regardless of distance. That consistency was profoundly strange. Normal comet outgassing fades rapidly as the comet retreats and freezes up. But this force maintained its proportionality with mathematical elegance. Avibe and his colleagues recognized what this mathematical fingerprint implied. Whatever was affecting 3I/ATLAS followed an inverse square law just like gravity itself. But it couldn't be gravity. Gravity pulls inward, and this force clearly pushed outward. Something real, following physical laws we could measure, was at work. At 270 million kilometers from the Sun, the research team calculated what that 0.00002 acceleration ratio would mean physically, an offset of roughly 54,000 kilometers. That's a gap wide enough to fit several Earths side by side. But the truly remarkable moment came when they converted that spatial offset into angular measurement from Earth's perspective. At 3I/ATLAS's distance, 54,000 kilometers translates to about 0.7 arc minutes on the sky, just over 1/100th of a degree. Small, but well within detection capability. The swarm hypothesis had made a specific prediction. If trillions of tiny particles were accompanying the nucleus, lagging slightly behind due to radiation pressure, they would create a visible concentration of scattered light offset toward the Sun by precisely this amount. And when researchers compared that prediction with actual observations, something extraordinary happened. The numbers matched. Not approximately. The measured displacement of the brightest teardrop concentration sat exactly where the mathematics predicted it should be. Multiple astronomers on different continents, using different instruments on different nights, all captured the same geometric relationship within margin of error. For scientists who spend careers chasing patterns in noisy data, this kind of theory-observation agreement is rare and precious. The swarm model wasn't just speculation anymore. It had passed a critical experimental test, predicting a specific measurable feature that appeared in exactly the right location. The leading explanation proposes something that sounds like science fiction, but emerges directly from rigorous physics. 3I/ATLAS isn't traveling alone. It's accompanied by a vast cloud of fragments, potentially 1 trillion particles, each no larger than a grain of sand, each individually invisible to our most powerful telescopes. Even if these particles represent just 0.1% of the comet's total mass, their collective surface area could exceed the main nucleus by a factor of 100 or more. That enormous surface intercepts sunlight and scatters it in all directions. The photon pressure pushing on this distributed cloud creates the mysterious outward force JPL measured. And because the swarm's particles lag slightly behind the nucleus, their collective glow appears offset toward the Sun, generating the teardrop feature that initially baffled observers. This explains the perfect inverse square relationship in the JPL data. Radiation pressure from the Sun follows the same mathematical law as gravity. A particle swarm dominated by solar radiation pressure would naturally produce exactly the force profile that showed up in the observations. But perhaps the most mind-bending implication, photometric analysis suggests that up to 99% of the visible light we're detecting comes from the swarm, not the nucleus. The massive core contributes almost nothing to what telescopes capture. It's essentially invisible, drowned out by the glow of its own accompanying cloud. When we look at 3I/ATLAS, we're not really seeing the interstellar visitor itself. We're seeing a ghost, a luminous haze created by trillions of tiny companions that mask the true object at the center. When astronomers analyze the brightness profile of 3I/ATLAS, they measure exactly what this scenario predicts. Instead of a sharp, star-like point, there's a broad, diffuse halo with no clear boundary. The light gently fades into space, with maximum brightness concentrated in the Sunward offset region where the hypothesis said it should be. It's like shining a flashlight into fog. The bulb becomes impossible to see, overwhelmed by the glow filling the mist around it. 3IATLAS appears to work identically, its nucleus hidden behind the combined glare of trillions of particles reflecting sunlight. This revelation forces us to reconsider what we're actually observing. The swarm isn't just an accessory, it dominates everything we can measure. In a very real sense, the swarm is the observable object, while the massive nucleus remains a hidden inference. The implications ripple outward in disturbing ways. How did this particle cloud form? Did it originate in some distant stellar system billions of years ago? Was it created during a catastrophic collision? Or is the nucleus actively generating these particles, continuously replenishing a cloud that should have dispersed long ago? The stability itself is puzzling. Radiation pressure should gradually push these particles away, dispersing the cloud over time. Yet observations suggest remarkable coherence across cosmic distances. Something is maintaining this structure. And then there's the question that keeps researchers awake. How many other interstellar visitors have carried similar swarms that we failed to detect? Oumuamua, the first confirmed interstellar object, exhibited unexplained acceleration too. Could it have been surrounded by an invisible particle cloud? Did we lack the observational precision to properly characterize what we were seeing? If swarms are common features of interstellar objects, we've been fundamentally misunderstanding what we observe. We've been tracking ghosts while the real bodies remain hidden, drawing conclusions from the glow of accompanying debris rather than the objects themselves. The data from 3I/ATLAS suggests we're witnessing something fundamental about long-distance cosmic travel. Objects don't journey through interstellar space as isolated bodies. They accumulate material, generate particle clouds, carry entire systems of debris across light years. This isn't just about one weird comet. It's potentially about rewriting our understanding of what happens during the millions of years objects spend drifting through the galaxy. The global network of telescopes continues monitoring as 3I/ATLAS races outward. The window won't stay open forever. Within months, the object will fade beyond reach. But what we've captured already has changed the conversation in fundamental ways. The numbers, the geometry, the light profiles, the mathematical precision — they all converge on the same remarkable conclusion. We're not just tracking an interstellar comet. We're observing an entire traveling system, a hidden swarm of trillions of particles, creating forces NASA is still working to fully explain. The massive nucleus might be invisible, masked by its own luminous cloud that dominates 99% of what we see. This changes everything. If Oumuamua carried a similar swarm, if these particle clouds are common, then we've been misreading interstellar visitors all along. 3I/ATLAS is proving that the universe doesn't follow our textbooks. It operates on principles we're only beginning to understand. The swarm hypothesis passed its first major test. The math matched reality with stunning precision. But the bigger question remains. What else is out there that we've completely missed? Here's what I need from you. If this breakdown changed how you see interstellar objects, smash that like button right now. Drop a comment. Do you think the swarm is natural, or could there be something more? Subscribe to Galactic Breaking News and hit the notification bell because we're tracking the next major development in this story. More discoveries are coming, and you'll want to be here when they break. Thanks for watching. I'll see you in the next one.